Okay, it has been a long time since we have done this. I'm not expecting you to remember a whole lot. But in this, we need to move on. This is the problem we left off on. I left you with this problem asking you how many molecules of propane, C3H8, are in 16.4 times 10 to the 6 micrograms of propane. Then I asked this along with it. If at standard temperature and pressure, remember that's what STP stands for, what is the volume of that propane? We had already went and realized we got a mole conversion. We had not a mole, but a metric conversion here. Because we cannot do a conversion with this, with this prefix before grams. We had to get it to grams, which we did, and then we set this up. Now here comes the fun part. This is why you need a periodic table. And I need to get my periodic table up.
Should have kept it.
Well, we're going to multiply
Papers already.
We are.
I already have it.
Yes, please hold on to the periodic tables. I promise you I'm going to give you so many of them you could literally use them as wallpaper in your room. You do that, by the way, give me like a picture of that. So like in this, now we're going to set this first conversion factor. Now, I don't have a mole map up here, but I developed and rolled the mole map for you, and you copied it down on a separate piece of paper. And I said it was good for you to keep handy to use. So in this, here comes the first conversion. So we're going to have to use a conversion factor. And this is the thing. In this conversion factor, we got to think where we're trying to get. We're trying to get to molecules. But before we can get to molecules, we have to go to moles. Remember, they're called mole conversions. Why? Because everything goes through the mole. You will either be solving for, going through, or starting with moles. Somewhere in your calculations, there will be moles. So in this, I got grams, I've got mass, I've got to get to moles. So I want 1 mole of propane. I have to cancel out the mass of propane. Now here comes the fun part. This is why this is one of the really hard problems. There's a lot of things hidden within it. You can't just go on the periodic table and find the average atomic mass of propane. This is for elements. But you are going to use this piece of information that I've given you to help you into discovering and finding what we call the molecular mass. Man, I'm out of practice so bad, my handwriting is worse than ever. Molecular mass. I'm going to tell you what molecular mass is. And this is a good time to stress. The definitions I give you in this class, you'll never read within a textbook because I'm never going to write a textbook. And what's the point in giving you a textbook definition when you don't even really know? The goal of this is to bring the terminology down to a level where you know so that it brings you up. My goal is not to make you walk out of here and totally confused. The goal is for you to walk out here with an understanding. So in this, molecular mass is the mass. There is a difference between mass and weight, by the way. It's the mass of a compound / molecule taking the elements that make it up into account. It is a compound and molecule. Easiest way to describe that to you right now, we're not going to deal a whole lot with these compound and molecules right now, but later on we will. But a compound and a molecule are combinations of elements bonded together. Move my cleaning supply out of the way. I'm going to have to get a refill here shortly.
Mr. Hall, can you read that? I can't.
Yeah, it's a combination of elements bonded together. All that's just a big fancy way of me to say to you that compounds and molecules, they're not elements by themselves, they're elements together. So like everything you've learned within classes before, that's really what you're looking at here, compounds and molecules, like water. Water is a molecule. Salt is a compound. The difference between the two is salt has ionic bonds and water has covalent bonds. That's really how we'll determine the difference between the two, if it's a compound or a molecule. But all I want you to know right now, compounds and molecules are a combination of elements bonded together. So we have to find the molecular mass for the molecule of propane. So when we look at this in molecular mass, we have to take into account the elements that make it up. I'm going to show you how to find the molecular mass. This is crucially important that you can do this properly. So this is how I always start. I always start with the elements that's in it, and I write down however many of that element there is. So I have carbon, which is a C, and H, which is hydrogen. I write down next to the colon that I put the number of that element that there is. The number that's down below it, right here next to it, that is the number of that element that's in that molecule or in that compound. For this example, how many carbons? I have a 3. So there's 3 carbons. How many hydrogens? 8. So there's 8 hydrogens. Now in this, we're going to multiply to that. This is where your calculators come in. The average atomic mass.
Sorry.
You're okay.
Sorry. It keeps falling.
I know, it's okay.
What?
In this, you're going to take the average atomic mass. You're literally going to take the atomic mass off your periodic table. I'm going to say this to you right now, and I want to stress this so you'll get this. If you are ever going to go to mass or from mass in these mole conversions, you will be using the periodic table. In some form or fashion, you're going to use this periodic table. So in this, we go to carbon, which is 6, which you see right here. And we find that average atomic mass, which is right there. It's 12.01. And this is grams per mole. Yes, you can use atomic mass units because I know y'all are so smart you remember that. But in this case, what are we doing? We're doing mole conversions. This is why I want to use the grams per mole. Because look, we got grams here, we got moles here. The number will always follow grams. I'll stress it to you here in like 2.4 seconds. Because look at hydrogen here, number 1. He was number 1. Right there. Hydrogen's average atomic mass is 1.01 grams per mole. You're going to do that multiplication. If you can do that in your head without a calculator, you're a better man than me. or a better woman. 3 times 12.01. I get 36.03 grams per mole for the carbon. And then I get 8. Gosh, my numbers are awful today. 8.08 grams per mole for the hydrogen. So I add those together, and I get 44.11 grams per mole. Now this is what this is saying. Okay, in this, let's say I have 1 mole of propane. Out of that 1 mole, that 1 mole propane will have a mass of 44.11 grams. Out of that 44.11 grams of propane, 36.03 grams of it is carbon. 8.08 grams of it is hydrogen. But the whole mass of it is 44.11 grams. And here's the thing. When you come up with this molecular mass, what you will see, this number always follows gram. And that's important because look where I left the empty spot. Here with the grams. So 44.11. Now here's the beautiful thing that takes place when we do that. Go back to your algebra. I got grams in the numerator, and here I have grams in the denominator. It's grams of propane. So they cancel out. Leaving me with moles of propane on top, which is what we're seeking, what we're after. Now you're not done. At this point you could do that calculation in the calculator. I choose not to do that. I don't like to do that. I like to just carry it all out in one. So in this, we got to keep moving. I'm at moles. From the mole map, I went from mass to moles. I'm at moles. I've got to get to the molecules. And this is where I said don't worry about the units of knowing what you're going to use. I literally will have it in the question for you. Because I have to ask you for that unit. So how many molecules of propane are we looking at? So we got to set up another conversion factor. So I'm looking for how many molecules. So I want to be left with molecules. It's going to be on top. And what do I need to cancel? Leave. So I need moles to cancel. So moles of C3H8, which is propane. So, how many molecules are in 1 mole? It's a very special number. It's been a really long time since you've been in here. Is there anybody that remembers it? No.
3.
No. Avogadro's number, which is 6.022 times 10 to the 23rd power. And this is just like before. I have moles on top, moles on the bottom. What cancels? Moles. That leaves me with molecules. What am I looking for?
Molecules.
Molecules. So in that, I've reached molecules, I stop. Now it's time for me to get the calculator. So I'm going to get the calculator, and I'm going to type this all in. This is what I do. I do parentheses, 16.4 divided by 44.11. You can hit enter if you want. If you do that, you get 0.3 3717977783, which is fine. So that number is sitting here now, and I'll multiply that by 6.022. Second, comma, to get me the e to the 23rd power, and I end up with 2.23 90 times 10 to the 23rd molecules of propane.
Mr. Hall.
Yes.
What did you plug in? I was lost.
You're okay. This is what I did. I take 16.4. I divided it by 44.11. I divide that by 44.11. Hold on. Work. Should have a calculator on here. That's it. So this is what I did, is I did parentheses 16.4 divided by 44.11 in the parentheses, and I hit enter. I did that to get me that number because I know a lot of you guys are going to just punch that in like that, and that's fine.
Need for the following students to come to the office: Jalen Flinger, Madison Hicks, Haley Kennedy, that's senior Haley Kennedy, Olivia Lambert, Christy Martin, Peyton Morgan, and Torin Morgan.
You ready to take my stuff? Oh, what are we doing?
I would.
Take the way them up.
I would, just because it's pretty close to them calling you out. Just be safe. Okay, so once I do that, I leave that in the calculator. Don't retype that number out if you don't have to. So then I multiply it by 6.022. And here's where I'm saying, don't do that times 10 with the caret key and all that. Do second function and come down here at this comma right above the 7, hit it, and you see that E? That E takes the place of the times 10. I know it's been forever since y'all been here, so you probably don't remember that so much, but we'll make sure and cover that for you. Then you literally type the exponent at the end, so 2, 3, and hit enter. Now another way that I'll type that in, does that help, Sonny? Okay, I'm waiting. I'm waiting.
What are you trying to do?
You're okay.
No, that's cold.
Oh, it's so cool.
So where do you get that little E?
It's hit the second function button, and then it's right above the 7. It's that comma. Once you do that, it's like what's blue there is what it's going to put. So whenever you should do that, you should get a small capital E.
Okay.
Okay. Once I do that, you guys are probably going to want to type it in like this, and that's fine. Me, I normally type in like this. Did we get the same answer? Yes, it's totally fine. Now, if your decimal is off a little bit, and I'm not talking here, I'm not saying like right after the decimal you get like a 5. If you did that, you did something wrong. But if you're like somewhere right here at this 90, if you did not get 90, it could have been because of rounding error. Because you got 0.238. Remember, I go 4 places past the decimal. So I stop here at this 9, but there's a 6 behind it, so that rounds up, makes that a 0, and it pushes that 8 up to a 9. If your number is still a little off, back here at the end where this 8 and 9 is, you could be slightly off. Like your 89 could be a 91, or your 89 could be like an 87. That could be because you typed this number back in, this 0.3718, if you use it like that. If you stopped here at this point and you typed this number back in, that's what you're looking at could have also happened for you. Alright? Now, that's how much molecules of propane we have. That was the first question. We're still not done with the problem. We still have this one to take place. If at STP, what is the volume of that propane? If Mr. Hall asks you a joint question like this, realize something. I got to erase some stuff because I got to make some room. What are we going to start with? Our starting point. We're going to start right here, right? Then we're going to realize something. We're starting with this number that was given 16.4 times 10 to the 6 micrograms of propane. You have to convert that from micrograms to grams because there's a conversion factor, right? So we get 16.4 grams of propane. So then we're going to start with 16.4 grams of propane. Set that over 1. Then we've got to set a conversion factor up. Remember, it's a mole conversion. We have to go through moles. We got to get to moles so we can go to the other units. In order to do that, we're going to need mole on top. With this, just to really push, you need to be going, you need to be studying, okay? Those practice problems we work through, but don't forget the notes we went over either. That is so crucially important because next Tuesday, you will get to experience something you've never got to experience before. The chemistry fluids. They're very nice. Very enjoyable. It makes some kids cry, but hey, it's all good. You guys should do fine on this one. Just study. If you got questions, holler at me. Ask. I will be throwing, you've already got the videos for average atomic mass calculations and the metric conversions. I'll be doing the mole conversions tomorrow, and I'll be uploading that and sending it to y'all. If you have not signed up on Remind, you need to sign up on Remind. That's how I'm sending the videos, because it literally is like just a feed. Okay? So from this problem, we already figured out how many molecules of propane there is. In this, we have now, we got this standard temperature and pressure. Remember, that's what STP stands for here. So we need to find the volume of that propane. So I'm going to work as if I was working from this point. But I already told you, don't do extra work when you don't have to. So in this, I got 16.4 times 10 to the 6 micrograms of propane. I know I cannot do this conversion the way it's set up because I have a prefix. I just need grams. So I have to do a metric conversion. So I set it up. I will not set this up for you. You have to see it. You have to notice it. You have to catch it. So in this, write the number down. 16.4 times 10. Do something another. Figure out what something another is. I'm going from micro, which exponential value is -6, minus grams, which is 0, which equals -6 There's nothing here with the grams. There's no exponent, so I don't multiply anything, but I do add what I originally start with, which is 6. Negative 6 plus 6 is 0. 10 to the 0 power. And anything to the 0 power is 1. So it's just 16.4. So I set my problem up, 16.4 grams of propane. I set that over 1. Then I got to set up a conversion factor. These are called mole conversions. That's the key. You either be going through, finding, or starting with moles. Therefore, moles is where we're going to. Moles goes on the top. 1 mole propane is equal to how many grams of propane? Why'd I put grams on the bottom? Because I need grams to cancel. How'd I get the grams? You calculate the molecular mass, which I already showed you how to do. Here's the molecular mass from last week, so 44.11 grams of propane cancels. Now you can stop here and type that in if you want to. Me personally, I don't want to. I am just going to keep rolling on. Like now, I need moles of propane to cancel, so I got moles of propane on the bottom. I want to be left with what?
Where did the 44 come from?
44.11 is the molecular mass that we calculated last week.
And why do we need to use that in this?
Because you're having to get from grams to moles. 1 mole of propane has a mass of 44.11 grams. Any other questions? Okay, we're trying to be left with volume. So we have volume of propane, which would be liters of propane. The reason we're doing liters is because on your mole map you can look at it and see the conversion factor is literally in moles. So, if you remember the magical numbers, 22.4 liters, moles of propane cancels. And then we can type all that in our handy dandy calculator.
Where did the 22.4 come from?
That is the conversion factor number.
Okay, but I thought you said that was like 6.022 or something like that.
That is Avogadro's number. That's if you're going from moles to molecules, compounds, atoms, particles, formula units, such.
Okay, so what did we start out with?
You started with 16.4 times 10 to the 6 micrograms of propane.
Okay, that's that.
Yes.
Okay, what's that?
This gets us to moles.
What's that?
This gets us to liters, which is volume.
Okay.
Remember, we started with a really hard problem. We're going to start making it, like after I'm done here, we're going to do really simple. So 8.3283 liters of propane.
What are you using typing in the business line? Like 22.4?
The key here with this 22.4 liters, it's a constant. That's just something you gotta have in memory. Like Avogadro's number, you gotta have it in memory. So like here for example, I got that number is I took 16.4, I divided it by 44.11. I learned not to assume anything. The reason I did this is in the numerator, this is in the denominator. So it's division. You can hit enter on it like I did there. That'll give you the number of moles. So then we're here. The number's set in here. This number, the new number's in the numerator, this is in the numerator, so now we multiply by 22.4.
How did we get the 44.11?
Let's calculate molecular mass. Alright, find molecular mass. Remember what I told you, I take the elements that are in there. So I have carbon and hydrogen. Next to it I write however many is in there. So this is C3H8, so how many carbon? 3. How many hydrogen? I multiply with it the average atomic mass, or the mass, the atomic mass number off of the periodic table there, which is the bottom number, that average mass. So for carbon it's 12.01 grams per mole. Hydrogen is 1.01 grams per mole. And I multiply these out. 36.03 grams per mole. And then this is 8.08 grams per mole. And then you add all those together and it gives you 44.11 grams per mole. Which is where that number came from. Better? Alright, within this, something else I like to do calculator-wise, this is how I like to do it. I would have 16.4 divided by 44.11 in parentheses, and I want to multiply it by the 22.4. It gives you the same answer. Questions? I mean, you have no idea what's going on. Thanks for the honesty. Okay, that's a really hard one. So we'll ease it up. Let's come up with an easy problem. How many moles are in 16.12 grams of carbon? Comment number 6. Alright, so here we're breaking it down, breaking it easier, so it's not so hardcore as a problem, so you guys don't have to freak out as much. Alright, so in this, you literally take what you're starting with and write it down. So 16.12 grams of carbon. Set over 1. You're starting with mass. Can you do a conversion the way this is right now? When I'm asking it, thing you got to look at and say, it has to be in grams. It's in grams, so can we do that conversion and just go straight through? Yes. We're good there. But where are we trying to get? We're trying to get to moles. So here's the key. If you are starting with or going to moles, it's a one-step problem. You'll do one conversion factor. We're going to moles, so it's a one-step. I need one conversion factor. I'm trying to get moles, so what goes on top? Mole. So 1 mole of carbon is equal to how many grams of carbon? Why did I put the grams of carbon on the bottom? To cancel it out. I gotta get this to cancel. So in this, where am I going to get the number for this? Periodic table. So I go on there, average atomic number 6, right there. So that number right there, that average mass at 12.01, that's the number that goes in here. Do I multiply or divide these two? Divide, because one's in the numerator, one's in the denominator. So 16.12 divided by 12.01 equals 1.3422 moles of carbon. Now, was that one hard? That's what I'm saying. I did a hard one to start so that you see the whole beast. I want you to see the whole beast before we jump into this. Okay? This is a little itsy bitsy baby. Okay? So in this we got 1.3422 moles of carbon. All right? Any questions? Please, if you have questions, ask. Remember, leave your pride at the door. All right. How many atoms of carbon are in 1.3422 moles of carbon? All right, so you're going to do this how we start every one. Take what you're given and write it down. 1.3422 moles of carbon. Set it over 1. In this, what am I trying to get to?
Atoms.
So what goes on top?
Atoms.
Atoms of carbon. What's going to go on the bottom of the conversion factor? Moles. Why do the moles go on the bottom? Because it cancels out. So, in this case, in the conversion factor, 1 always goes with the mole. So moles of carbon will cancel. What's the number that goes there with atoms of carbon? Avogadro's number, 6.022 times 10 to the 23rd. So now we do that calculation. Do we multiply or divide?
Multiple.
Multiply, good job. I get 8.0828 times 10 to the 23rd atoms of carbon. Any questions on that? No questions? Oh. do, how many atoms of carbon are in are in 16.12 grams of carbon. You make it a problem? And this you start like we have every other one. Take what you're given, 16.12 grams of carbon, write it over 1. I can do a conversion factor set the way it is. Here's the thing, and this, listen, don't be ashamed if this helps you, do it. Get a plan together. So we're starting at mass. I'm in grams, which is good. Now, I gotta get to atoms. So I'm trying to get to atoms of carbon. Can I just directly go from grams to atoms? I think it was a no.
Yeah.
No. What do I got to go through first?
Moles.
Moles. We got to get the moles first. Once I get the moles of carbon, then can I go to atoms?
Yes.
So that's literally the steps that we got to do. So I'm starting here at mass. I got to get to moles. Set the first conversion factor. I want moles. So moles of carbon goes on top. The number on the bottom is the average mass from the periodic table, which is 12.01 grams of carbon. Grams of carbon will cancel. That gets me to moles. Now I got to get from moles to atoms. So I set up another conversion factor. So I need moles of carbon to cancel. Moles of carbon goes on the bottom. It cancels them out. I need atoms. So 6.022 times 10 to the 23rd atoms of carbon go on top. I'm left with atoms of carbon, which is what I'm looking for. So you do that calculation, and you should get a magical number of 8.0828 times 10 to the 23rd atoms of carbon. It should look really familiar to you. The reason it should look very familiar to you, you just did that. But you did it in 2 problems. Reduce with purpose. Did you end up with the same numbers? Yes. We ended up with the same numbers, but what's the difference in these? These are the steps that you're doing. I do this to show it to you. When I did the big, huge, nasty problem, you all feel like you have no idea what's going on. But if you take it a step at a time and break it down, it'll go so much better and smoother for you. However you're comfortable with doing it, do it. I don't care, as long as you get the right answer. Capiche? Is there questions? No questions?
Yeah.
Yes.
When are we gonna have to set it up like, I don't know what that problem's called. The problem where you have to put it on the line. Dude, I don't know what that problem's called. The problem that you said we had to set up ourselves.
The conversion?
Yeah, yeah.
That's when, like, you don't start at grams. It's also, like, in volume, if I start you with the volume, it's not in liters. You got to see the conversion factor yourself. The key to that is the two big ones is mass and volume. Mass has to be, you have to start in grams. No ifs, ands, or buts about it. So if I start you with something that is not grams, you have to notice you got to convert to grams. Volume has to be in liters. You have to use be in liters. No ifs, ands, or buts. I can start you in 1,000 different places. What matters is that you start with grams or with liters. I will start you with a conversion factor sometimes, because I have to get you to where you can critically think. You have to catch these things yourself. If I give you a fish, I feed you for a day. If I teach you to fish, I feed you for a lifetime. That's what these are. I've got to teach you to fish. Any other questions? This is a regular question.
So where you have 16.12 grams up there, that's where you're starting this?
Yes.
Okay.
If I would have started you with 16.12 milligrams, can you directly do the conversion factor? No, because it's not in grams. It has to be grams. So you'd have to convert that. And I won't spell it out for you. I know you can't see it, but I'm smiling. You see my fat cheeks are all up there. I'm smiling. You know what? You know what now is a good time for it?
An ice
Introduce
break.
you. What?
An ice break.
You get one tomorrow. Now's a really good time to introduce you to some good friends of mine. You know how I told you I got tricks that I use throughout the whole year that I literally keep in my back pocket? Introduce you to some really good friends of mine that are perfect little tricks to pull out at any little moment.
Extra credit.
No. The 7 diatomics. There are 7 special elements. And I'm giving this to you because it's very important that you know this, especially if you're going to make calculations with them. The first one that's up, he's kind of Mr. Lonely. He's all by himself. Nobody cares for him. He's number 1. Hydrogen. Number 2, and the other 6 of this, they're kind of pals. Best of buds, hanging out all the time. Number 2 is nitrogen. The third one, oxygen. Fourth one is fluorine. Fifth is chlorine. I'm going to misspell that one. Chlorine. 6, bromine. 7th is iodine. Here's what's special about these 7. They're called the 7 diatomics for a reason. When we call them the 7 diatomics, it's because The key word is diatomic. They exist in nature bonded to themselves. So exist in nature bonded to themselves. Super, super important. And I'm going to show you a trick. Because I'll be honest with you, I don't even remember the list. I remember the trick, and from the trick, I get what I'm looking for. Hopefully you can see periodic table. Kinda. Alright, so on here, I'm going to show you the trick with your periodic table, and this is where it comes in at. I don't remember the 7 like a list. I remember the 7 based off the trick. The key is hydrogen. Hydrogen's by itself. I always remember hydrogen by itself, and then from there I remember the number 7. Because when you look at the other 6, they literally make a 7 on the periodic table. So you start at nitrogen, you go oxygen, fluorine, chlorine, bromine, iodine. There are the 7 diatomics. That is the simplest way to memorize them. And I give that to you, why? Because on your quiz you will always be given a periodic table. Except for the element quiz, because that's kind of like giving you answers, and that's dumb. So there's a little trick. Now this is why it's important. And this is how sneaky I am. I'm going to show you the trick. I'm going to show it to you right now. What is the volume of oxygen at STP if the mass is 12.8 kilograms of oxygen? So here's where it is. Okay, first off, I got you a trick with another trick lined in here. This is why mole conversions are so much fun. Me and Miss Cole see eye to eye with what is fun. If you've had Miss Cole for class. In this, there's a conversion factor. I did this to you on purpose. Okay? Because we're going to go, you're automatically going to start, you want to write down what you started with. Alright, there's 2 things here. First, oxygen. Whenever I say oxygen, is oxygen with any other element? No, oxygen's by itself, so it's a diatomic. So it's O2. I don't have to give you any other information besides the name of the element. If I give you the name of the element, then you know that it is bonded to itself. But here's the other little trick. Can you directly go from kilograms and start converting? No. You have a metric conversion you have to do first. So you guys see what 12.8 kilograms of O2 is for grams of O2. Write the number down. Times 10. If there's something another, kilo. Exponential value is 10 to the third, so 3 minus grams is the base unit, so that's 10 to the 0. 3 minus 0 is 3. there's nothing to multiply or add, so it's 12.8 times 10 to the third power. So, we can now work with this. Write down what you start with. 12.8 times 10 to the third power grams of O2. And this is where the trick is. Set it over 1. First conversion factor. I'm trying to get from grams to volume, but I have to get to moles first. So mole has to go on top. 1 mole of O2 is equal to how many grams of O2? Here's the trick. Now, a lot of you are going to want to make this mistake. This is where the trick comes in at. If you look on your periodic table, what is the average mass for oxygen? 16.00, but that's for 1 oxygen. That's not 2 oxygens bonded together. That's oxygen, 1 single oxygen, all by itself. You have 2. So it's not 16.00. The diatomic, you take the average mass and you multiply it by 2. So you get 32.00. Grams of O2 cancel. Set this up. 1 mole of O2. On the bottom, because I'm trying to get it to cancel, I need volume. So liters of O2 goes on top. So 22.4. Mole of O2 cancel. We can now punch in the calculator. I get 8,960 liters of O2. Okay. Yes.
I'm still confused like how, you know, if you're supposed to be going to liters, or where you're supposed to be going.
Okay. This is where, let me know if this helps. Find your end point. Okay, where are we trying to stop? For that, just look at the question. What is the volume? So the end point is volume. That's where I'm ending. You got to find your start point now. Where do you start? For that, you're doing calculations. I got to give you a number. And I give it to you. The mass is 12.8 kilograms. So you're starting here. So you're starting with mass. And you're going to volume. But the key to that is how you're going to do it. And that's why I did that mole math with you guys, because think of how the mole math is broke out. With your mole math, you have the mass. You can go to moles. Let's do, I'm just going to say atoms. And also go to volume. these are like your boxes. These are your stop points. Like a map. You're literally you're gonna start at one point and you're gonna drive to another. Now, sometimes you have to drive through something to get to it. In this case, that's literally what we have to do. Because I gotta go from Mass, which in there I've hidden a conversion. We gotta go to Moles. And after Moles, we can go to volume, and that's where we'll stop. Does that help? Are you just telling me yes to make me feel good?
No.
Okay. Because if it's not helping, tell me. I'm not perfect. Yes.
How did you get that number?
Which number?
The 8,000.
Okay. I got 12.8 times 10 to the third. I divided by 32.
Oh. I thought you were multiplying.
No. You're good. This is literally like Whitney. This is why I literally do this. Is because I look here. This is in top. That's in bottom. So divide. If they're on opposite sides, you're going to divide. These numbers are on the same side, so I'll multiply.
So you didn't have to multiply 22.4?
If you have to,
So I said I need to remember some
then you got to multiply by that. 22.4. You guys okay? Everybody's like super quiet right now. I will be honest with you, this is the part in the class where you should feel like you're getting hit in the face by a 2x4. If you're feeling that right now, don't feel bad. That's why I gave you those mode conversion problems that you're going to do tomorrow. And with that, how many did I give you? Should be more than that. It's 9. I gave you 9 of them. Guys, on that, like, I literally created this. This is not something by somebody else. I created this myself. And it's like 1 and 2, and I want to say 3 and 4. Those are literally just simple stepping through. Okay, like those 1 steps, like those problems we just did here with carbon. That's what those problems are like. But then when you start getting to 4, 5, at those moments, it gets a little harder. And then when you get down to like 8 and 9, I'll be honest with you, it's really hard. Like, it's created that way on purpose. Because if you come to me on Friday and you see me and you say, Mr. Hall, I was good with 1 through 4, but 5 through 9 got me. I know where you're at. It gives me a point to where I can talk with you, have a conversation, know what's going on. Okay? So don't feel bad. Now, I do recommend signing up on Remind so you can get the video. Because the video helps a lot more than you think. Did anybody watch the other videos? Okay. I promise the videos help more than you think. Because literally I did it last year. Kids felt like they were lost. They had a quiz the next day. I did the video. They go home, watch the video, and I had half the class come in and looked at me and told me, thank you so much for the video. I now understand what I was doing. Because you're literally going to hear me explaining why you're getting the answers you're getting, why those are the correct answers. So it's there to help you. If you don't want to watch it, don't watch it. I'm not telling you you have to. I'm saying it's there as a choice and an option to help you. Okay? All right. Make sure you remember your 7 diatomics. Let's see here. Let's do. Let's give you guys one on your own. want you guys to give this one a shot. Okay, take your time. What is the volume at standard temperature and pressure of 16.9 times 10 to the 6 milligrams of carbon dioxide? Here's the atomic number for carbon, there's the atomic number for oxygen, for you to find it on the periodic table easier. I want you to try this.
So that's yellow.
Yes. Yep. Let's work through this. So as I went around, majority of you caught my first trick. The milligrams. You can't go from 16.9 times 10 to the 6 milligrams and go to moles. That's a no-no. You tried that? That was a mistake. You have to get this thing converted first. So in that, you got 16.9 times 10 to something another, and we're going to make grams of carbon dioxide. So to look at this and do this, I'm going from milli to grams. Milli exponential value is -3. Subtract from it, grams, it's the base unit. So it's -0, it's equals -3. Don't miss the other steps. There isn't a number here, there isn't an exponent with grams or the milligrams, so you don't have to multiply it, but you started with a number. We started with 6. We have to add 6 to that to give me 3. So we'll have 16.9 times 10 to the 3rd grams of carbon dioxide. That's our real starting point. From this point, we'll set this over 1. And we got to convert. Now, first conversion. I'm starting with mass, trying to go to volume. Can I go straight from mass to volume? No, you got to make a pit stop at moles. So 1 mole of carbon dioxide. I need grams of carbon dioxide to cancel. So grams of carbon dioxide goes there on the bottom. Excuse me. What number goes here?
Hold on a second.
Okay.
44.01.
You good? Okay. 44.01.
How'd you get that number?
That's where I'm going to go.
Okay.
Molecular mass. This is what you got to realize. This is a molecule. We have to find the molecular mass for it. So in that case, start with our elements. So we have carbon and we have oxygen. How many carbons are in carbon dioxide? 1. Because there's not a number here. But that's back to like math. If you've got an equation or formula and it's got x in it and there's not a number in front of it, there's understood to be a 1. It's the same thing here. There's not a subscript there, so it's understood to be 1. So I have 1 carbon. How many oxygens? 2. Don't make a mistake here. In this case, oxygen is bonded with this carbon. So the whole diatomic thing goes out the window. Diatomics are only when they're by themselves. The reason we got a 2 here is not because oxygen is diatomic. It's because there's a 2 sitting right there with the oxygen. Got it? So now we take the average mass off the periodic table for carbon, which is 12.01 grams per mole. And for oxygen, it's 16.00 grams per mole.
Would it
Mol-
be 32?
Yes. 32, do you mean that 16 be 32?
Yeah.
No, that's what I'm saying, is don't mix up and pull the diatomic thing in there. That diatomic, it'll be 32 when it's oxygen by itself. But where oxygen is bonded, that goes out the window. This will be 32.00 because per every molecule I have 2 oxygens. So per every mole, every molecule within that mole, there's 2 oxygens in it. That's why I introduced the diatomics early today, and I didn't wait. Add those together, you get 44.01 grams per mole. Okay? That's where the 44.01 came from. Please, please, please. I'm doing this, I'm repeating myself multiple times because hopefully you're going to go watch the video and you're going to hear me say this. Oxygen is bonded with carbon. It's bonded with something. The diatomic thing is out the window. Diatomics only apply when it's by themselves. Alright? At this point, we now have grams of carbon dioxide canceled. So now we step to the next conversion. We're at moles. What are we asked to end with? Volume. So what's the volume got to be in? So liters of carbon dioxide. And I need moles on the bottom. So a mole of carbon dioxide to cancel out my moles of carbon dioxide. What number goes with liters? 22.4.
If it's not at STP, would it be different?
If it's not at STP, you say cannot solve, not at STP. So now you punch that in the calculator. I'm going to give you a second. I want to see what you get. Make sure you get what I got. Hopefully you guys get 8,601.6814 liters of carbon dioxide. Any questions? Anything at all? Okay. has a second on that?
Is that standard temperature impression?
What did I tell you in class? Anytime I give you values, it's not.
So, so
Correct. This right here is how you would answer
A
this.
students are released at this time.
This is how you would answer this. Not at STP. Cannot solve. And you would leave it at that. Once you're done with that, you put the calculators up. Listen to me. As you're doing that, guys, very important, do these mode conversions, get the practice in. You'll be seeing me Friday, so we can do a couple practice problems if we need be. But we're pretty much done with the mode concept. I may throw a couple more problems at you, a couple more tricks just to, see how you're feeling. Communicate with me on Remind if you guys got, if you feel like you need some more practice problems, let me know. Let me know in advance so I can type those up. Along with that, I do plan on moving on Friday. Just so you are aware, we will move on, but everything you've learned to this point is fair game for your quiz.